Hello. Hello and welcome to the Studify Plus. Here we will continue our lectures on two-port network analysis. So we are again starting our lectures from two-port analysis. In last lecture it was discontinued due to the power. Okay. Just wait for a minute. Okay. So let's start how we can analyze one Z parameter. So we have talked about Z parameter and now we are starting few more problems on Z parameter. So what I have seen, we have seen that we can analyze the Z parameter only if the I1 and I2 are not dependent on each other. If I1 and I2 are dependent on each other, then one current will make another equal to 0. If other variable is also equivalent to 0, all parameters will be infinite. Now, the discussion on Z parameter can be divided into 2 or 3, 4 or 5 categories. So all question belongs to this categories only. One, we are having only resistive network. Then we are having only dependent. We are having dependent source. Then some theorem based problems. So let's see one more network and let's try to calculate one more example for two-port network, and that example is Z parameter calculation. Z parameter calculation for this network. Let's say I have this network. I have a network like this. Value is Z1, let's say. This value is Z2. This value is Z3. A network is there, and for this network we are interested in calculating the Z parameters. Let's say this is your first port and I am calling this terminal as 1. I am calling this terminal as 1 dash, and here we are having another terminal 2 and 2 dash. What else we know? We are interested in this. This is value V1. This is I1. This is V2. And this current is I2. This is one of the variety in which we are interested in calculating the Z parameter. This is one of the variety for which we are interested in calculating the Z parameter. Okay, so how to calculate it? So to calculate this, let's say I am making I2 equal to 0. We are making output port open circuit. So let's draw the, when we say the output port is open circuited, let's draw the equivalent across V1 and 1 dash. So let's say this is terminal number 1. So this is, we are on terminal number 1. So can I say Between terminal number 1 and 2, what is connected? Z is connected. So let me redraw the circuit here. Between terminal number 1 and 2, between terminal number 1 and 2, what is connected? Between terminal number 1 and 2, Z1 is connected. So let me call this value as Z1. Fine. What is connected between terminal number 1 and 2 dash? Z4 is connected. So let's take this is Z4 and we are calling this terminal as 2 dash. So these are two terminal 2 and 2 dash. What else is given? From 2 to 1 dash a Z3 is connected. So can I say from here to here, from here to here, from 2 to 1 dash, from terminal number 2, from terminal number 2 to 1 dash, one Z3 is connected. So let me write this value as Z3. And from 2 dash to 1 dash, from 2 dash to 1 dash, Z2 is connected. So can I say from here to here, okay, this is connected. What else is given? We are making current I2 equal to 0. So you can make this current equal to 0. So current going inside I2 is equivalent to 0. So this current is 0. And this potential is known as now this is one of the easy network for us to calculate the Z equivalent. So can I say if this value is V1, can I say if input pole to voltage is V1 and current is I1, if this current is I1, can I say the current going in this branch is what? And current going in this branch is what? If I2 current is 0, this two branch will appear in parallel. If this two branch will appear in parallel, what is current here? The current in this branch is given by what? The current in this branch is given by Z2 plus Z4. Let me write it here. This current is given by the current in the first branch is given by Z2 because these are parallel branches, and current in parallel branches is given by, let's say I am writing that current as Ix. So Ix current is equivalent to what? This resistance Z2 plus Z4, Z of 2 plus Z of 4 divided by Z1 plus Z2 plus Z3 plus Z4. Correct? And what is current going inside? I am calling this current as Ix and I am current as Iy. And what is value of Iy? So you can say the value of Iy is given by this two, Z1 and Z3. Z1 plus Z3 divided by what I am using? The current distribution principle I am using for this, and this value will be Z1 plus Z2 plus Z3 plus Z4. Correct? We know both the current. Now we are interested in V1. So what is V1? V1 is equivalent to, this V1 is equivalent to potential drop across Z1 and potential drop across Z3. As we know that the current is same in both the branches because no current is coming from the second terminal. So can I say the value of V1 here, this times of I1 and this times of I1. अगर मैं बात करूं KVL से, using KVL analysis, if I say what is the value of V1, so value of V1 is given by, the value of V1 is given by how much? Z1 plus Z3 into I1 into Ix. And what is Ix? Ix is available in terms of I1. So you can say V1 is equivalent to Z1 plus Z3 into how much? Z2 plus Z4 divided by how much? Z1 plus Z2 plus Z3 plus Z4. And this much of I1, so I can write this current as in denominator. This is V1 divided by I1. So this ratio is known as Z11 of the Z parameter. This ratio is known as Z11 of the Z parameter. Correct? So Z11 parameter is given by this. Let's say we are interested in this V2. What is value of V2? So you can say, what is potential drop of the network? The potential drop of the network is this. Ix into Z1, and this potential drop is Iy into Z4. So we can apply one KVL inside this loop. Let me call this number as loop number 1, and I am applying KVL in loop number 1. You can apply the KVL in loop number 2 also. So you are starting from here. This value is what? We are applying KVL in loop number 1. So what is KVL in loop number 1? अगर मैं KVL देखूं यहाँ पे तो कितना होगा? यहाँ से स्टार्ट किया -2 plus this voltage I am writing it V2. This value is -2 plus, where we can call it Ix Z1. And again we are going plus to minus, so I will write minus of Iy into which potential? Z4. This Z4. V2 can be written as Iy into Z4 minus Ix into Z1. The value of Iy and Ix is known. What is the value of Ix? The value of Ix is given here, Z2 plus Z4. Z2 plus Z4, the value of Iy, Z1 plus Z3. Z1 plus Z3 into Z4 minus value Z2 plus Z4. Z2 plus Z4 into Z1 and whole divided by what? Z1 plus Z2 plus Z3 plus Z4. This much times of I1 equal to V2. So you can calculate one more parameter, that parameter is equivalent to V2 divided by I1 by making I2 equal to 0, and that parameter is known as Z21. And what will be the value of Z21? The value of Z21 is given by Z1 Z4, Z3 Z4, Z1 Z2 and Z1 Z4. Okay, nothing. Okay, one term is cancelled. Z1 Z4 from here, and from second term we are having Z3 plus Z4. Then we are having minus Z1 Z2 minus Z1 Z4 divided by sum of all resistances. So you can say that it is Z1 plus Z2 plus Z3, और इन चारों resistance का sum हो जाएगा. Z1 Z4 and Z1 Z4 cancel. From here you cannot take anything as common. So what is Z21 parameter? Z3 Z4 minus Z1 Z2 divided by summation of all resistance Z1 plus Z2 plus Z3 plus Z4. And that parameter is what? That parameter is Z21. Two parameter we can calculate by making I2 equal to 0, and remaining two parameter you can calculate. Remaining two parameter you can calculate by making I1 equal to 0. So for I1 equal to 0, again you can redraw the circuit and calculate all the parameters. As I have told you, जैसा कि मैंने आपको बताया है कि पूरा डिस्कशन जो है जेड पैरामीटर पे जितने भी प्रॉब्लम्स आएंगे हम सारा कुछ देखेंगे. द करेक्शन ऑफ जेड पैरामीटर्स, वी विल टॉक अबाउट द कंडीशन फॉर जेड पैरामीटर कि कब नेटवर्क सिमेट्रिकल होगा, क्या केवल पैरामीटर को देख के ही बताया जा सकता है. वी कैन by just looking at the parameter can we comment on the reciprocity and symmetrical property of the network. We'll talk about everything, but these questions are divided into 3 or 4 categories. Let's see that category of question one by one on Z parameter. अभी हम केवल Z parameter के बारे में बात कर रहे हैं. Let's see the first category of the question. This is the first question, and what this question is saying: a network is given 2, 8, 12 and 4, and we are interested in what? Z parameter. यहां अगर हम इस नेटवर्क को ध्यान से देखें तो इट इज वेरी इजी फॉर मी टू कमेंट ऑन Z parameter by looking at the which type of network, the T network, or we can say we are very comfortable if this delta is converted into the star. So can we convert this delta into star and calculate the Z parameter? So this value is, this is V2, this value is I2, this value is V1, this value is I1. Okay, this is the whole story. So we are very comfortable when we comment on Z parameter by looking at the star network. So can we convert this delta into star? Let me draw it here. The delta which is formed by these 3 resistances can be converted into the star. From here to here to here. If we form this delta, we can calculate the value very easily. What is value of this? This is 12 into 4, means when you convert this, multiplication of this 2 resistance divided by sum of all resistance. So 12 plus 8 is 20, 20 plus 4 is 24. So this is 48 divided by 24, the value of this resistance. What is value of this resistance? This is 32. 8 4s are 32 divided by 24. And what is value of this resistance? This resistance is having value 12 into 8 divided by 24. Once you know all the values, because what is delta to star transformation? The multiplication of these 2 resistance divided by sum of all resistance. So let me redraw the network. Now, after transformation, network after transformation, or let me draw it on next page. The network after transformation looks like this. We are having network after transformation. How network looks like after transformation? After transformation, network looks like this. This is 2 ohm resistance, and this is 12 2s are 4. So 2 in series with 4 is 6. So we are having 6 here. We are having 6 ohm here. Then what we are having? Here we are having 2 ohm here. This is 2 ohm. What else we are having? We are having here 32. So this is 4 by 3 ohm. Now we have converted this whole network. We have converted this whole network into one star network, one T section. And for T section, we are very much clear about the Z parameter. So you can say if this is V1, if this value is I1, if this value is V2, if this value is I2, what I can say? I can say that what is Z1 parameter? So we have talked about it. Z11 is summation of these two things. Why? Because if you are making I2 equal to 0, this Z11 will be what? We can write directly. We can write directly. This parameter is 6 plus 2. So this parameter Z11 is 8. What is this parameter? Z1, if I am making I2 equal to 0, Z11, and this parameter is what? 2. What is this parameter? Z22, Z22, and this parameter is also 2. Because if you make one thing, if you making I1 equal to 0, the value of V2 divided by I2 ratio and the V1 divided by I2 ratio will be same. And what is this parameter? This parameter is 2 plus 4 by 3. All the parameters you can calculate very easily. So it is very simple to comment on. It is very simple to comment on Z parameter when T section is available to you. I hope this is clear. Let's go for the next. What is next? Next, when let's say when we are having dependent sources in the network. So what is this? Is the second category. So you can say this is the second type of questions you will get. Type 2. What is type 2? Type 2, you are having this dependent source inside the network. So can I say type 2 category, how we will approach it? Let me, oh Allah. Type 2 category. So you are having 5 ohm resistance here. A 5 ohm resistance, then 20 ohm resistance, then 10 ohm resistance, $25, this value is minus plus, for I1, fine, and we are having this. This value is I1, V1, this value is I1, 1, 2, 3, 4 components are there in our network. 1, 2, 3, 4 components are there. This value is V2 and this value is I2. What is our first analysis? पहला जो एनालिसिस होगा वो इस बात से रिलेटेड है कि लेट्स मेक I2 इक्वल टू 0, कि मेरे पास जो आउटपुट करंट है I2 या आउटपुट पोर्ट को ओपन सर्किट कर दिया जाए. तो लेट्स मेक I2 equal to 0, and by making I2 equal to 0 we are interested in V1 and V2 in terms of I1. So if I am making I2 equal to 0, and as we know that V1 and V2 are voltmeter, so what is current here? The current here in the first loop is given by using KVL, and what this says that V1 is equivalent to, what is V1 equivalent to? 5I1 plus 20I1. I1 plus 20I1, because net current going in 20 ohm is I2 plus I1. What is current going inside this? The current going inside this branch is I1 plus I2, but we are taking I2 equal to 0. So if अगर मैं I2 को 0 बना देता हूँ तो इस ब्रांच में जाने वाला करंट कितना होगा? I1 ही होगा. तो KVL लगा के हम देख सकते हैं व्हाट इज वैल्यू ऑफ V1. V1 इज इक्वलेंट टू 25I1. तो यहां से जो V1 by I1 का रेशियो आएगा, दैट पैरामीटर इज Z11 पैरामीटर, दैट इज रेशियो ऑफ V1 डिवाइडेड बाय I1 by making I2 equal to 0, and we call this parameter as 25. तो पहला पैरामीटर मुझे मिला 25. So always remember how we calculate it. By making I2 equal to 0, calculate V1 and V2. Now let's calculate the V2. V2, we can apply the KVL in loop number 2. Let's apply KVL. Where we are applying KVL? Here. Okay. If I am making I2 equal to 0, if I am making I2 equal to 0, this current is 0. So what is potential drop of this point? The potential drop of this point is 20 times of I1. If 20 times of I1 is potential, we can apply the loop in this in these three components. What we can say, this branch is open. Don't think that V2 is the source voltage. No, V2 is the voltage. This is dependent variable. Dependent variable means you are having some measuring devices. So if I make this current equal to 0, the potential drop across 10 ohm is also equivalent to 0. If this value is 0, from here you can write this value as 20I1. You are going negative to positive. What is potential drop across 10 ohm? It's 0. Then you can write this as a 4I1. And this value is equivalent to what? V2. So you can say the parameter V2 divided by I1 by making I2 equal to 0, that parameter is Z21, and Z21 is given by 24 ohm. 24 ohm is this parameter. This is one part of the analysis. What else we can do? We can similarly we can make I1 equal to 0 and can calculate the network. So can I say I am going for the network where we can say I1 is equivalent to 0. If I make I1 is equivalent to 0, अगर I1 को अगर मैं 0 ले लेता हूं तो ये पैरामीटर का वैल्यू कितना हो जाएगा? तो पैरामीटर का वैल्यू हो जाएगा, I1 को 0 करते ही आप यहां देखेंगे कि दिस इज current dependent voltage source. So if you make I1 equal to 0, you can replace this, you are making the value of this voltage source equal to 0, and the value of voltage source equal to 0 means you have to remove this voltage source by a short circuit. So how your network will looks like? When we are making I1 equal to 0, when you are making I1 equal to 0, this is your input port, and here we can say 5, this is 5, this is 10, and we are making I1 equal to 0, so you can, if for I1 equal to 0, you can replace it by short circuit. So we are having 5, 20 and 10. These two parameters, this value is 10. Now what we know? We know that this value is V2, this value is I2, this value is V1, and I am taking I1 equal to 0. So by making I1 equal to 0, again I am interested in what? Again I am interested in V1 and V2. So can I say, what is potential drop across this component? So this potential drop is 10 times of I2. What is potential drop across this component? This potential drop across this component is 10 times of I1. And what is potential drop across this component? It is 0, because I1 is equivalent to 0. So I into R is the potential drop across. So what is value of V1? By making I1 equal to 0, again what we have to do? Again we have to calculate the V1 and V2. So you can say the value of V1 is nothing but this potential drop is 0. So this is equivalent to 10 I1. So can I say the value of V1 divided by I1, V1 divided by I2. This value is not 10 times of I1. This value is 10 times of I2. If this value is 10 times of I2, can I say this is V1 divided by I2, V1 divided by I2, and this value is 10, this value is 20. I can say V1 is equivalent to, V1 is equivalent to not 10, it's a 20. This value is 20. I2. So you can say V1 divided by I2 ratio is 20, and that ratio is given by Z12. So Z12 is also known. Which parameter we have to calculate? So story of the Z parameter is very simple. Make I1 equal to 0, calculate the 2 parameter. Make I2 equal to 0, calculate 2 parameter. Make I1 equal to 0, calculate the V1 and V2 in terms of I2. Make I2 equal to 0, calculate the V1 and V2 in terms of I1. So this is the idea. Now we are interested in this. So you can say this is 20 I2 plus 10 I2. So V2 can be written as 30 times of I2, or you can say the V2 divided by I2 ratio is Z22, and Z22 is what? 30. Now we know all the parameters. 2 from making I2 equal to 0, and remaining 2 parameters we can calculate by making I1 equal to 0. So what is first variety of question? First variety of questions when you are having resistive network. Second variety of question when you are having dependent source in the network. Let's take one more question on the dependent source. And this question is saying what? We are having a dependent source of 12 Vx, and this value is Vx. So calculate impedance parameter. Impedance parameter means Z parameter. Okay. So can we say this value is what? This value is V1. We are taking this current as I1. We are making this value as V2. We are making this current as I2. Okay. So how we can calculate this parameter? So can I say let's make I2 equal to 0. So what is our first thing? First thing we are doing in this network. First thing we are doing in this network is making I2 equal to 0. So if I make I2 equal to 0, how my network looks like? So this is 20 ohm. 50 ohm. 20 ohm, 50 ohm, 100 ohm. Then we are having 60 ohm. Then we are having one dependent. And what we are saying in this network, we are saying that the current which is entering from the port number 2, that current is equivalent to 0. I am making this current equal to what? And we are calling this potential as, and we are calling this current as I1, and we are calling this potential as V. Correct? What are the values of resistances? 20, 50, 100. So this will be 20, this will be 50, this will be 100, and this potential drop is Vx. This is question based on dependent source, Vx, and the next resistance is 160 ohm. This value is 60, and this value is minus plus 12. So we are interested in everything, but one variable in the question is what? One variable in the question is undesired variable. So how to deal with that variable? So if I am making I2 equal to 0, if I am making I2 equal to 0, can I say, if I am making I2 equal to 0, this potential is what? We can say this potential is V2. This current is I1. So what is this? This current is I1 and current in this branch is what? Vx divided by 50. Current in this branch is what? Vx divided by 50. That current is entering into this branch. Because potential drop is given as Vx, अगर potential drop Vx दिया है, resistance का value है 50, फिर यहां से फ्लो होने वाला करंट का वैल्यू कितना होगा? तो यहां से फ्लो होने वाले करंट का वैल्यू हो जाएगा, टोटल इनकमिंग करंट था I1 और नेटवर्क नोड से दूर की तरफ जा रहा है कितना? Vx minus 50. So this is the net current which is going in both the branches. ये इसमें भी जाएगा, this will enter into the 100 ohm and this will flow through this branch also because we are taking I2 current equal to 0. So what will be the potential drop across? Let's call this potential drop as VR. So what is the value of VR? You can say the value of VR is nothing but 100 times of I1 minus Vx divided by 50. अगर मैं इसको लिखता हूं तो this value is what? VR equal to 100 I1 minus 2 Vx. If you multiply 100 by I1, it is 100 I1 and 100 divided by 50 is minus 2 Vx. The same current will flow through this branch also. I am calling this potential as VR1 and I am calling this potential as VR2. So what is the value of VR2? Can I say the value of VR2 is given by, let me use some different pen. The value of VR2 is given by 60 times of I1 minus Vx by 50. And you can say the value of VR2 equal to 60 times of I1 minus 6 by 5 is minus 1.2. So let me call this equation number 1 and this is equation number 2. Now can we say all the potential of this loop, when I consider this middle loop, I am consider this loop as middle loop. So all the potential of this middle loop is dependent only what? Ix and Vx and I1. I1 is desired parameter. Which one is undesired parameter? Undesired parameter is Vx. So we can find the Vx in terms of I1. Let's apply the KVL in loop number 1. So when I apply the KVL in loop number 1, when we apply the KVL in loop number 1, how this KVL looks like? We can say this KVL will looks like this. When KVL is loop number 1 is applied, this is minus 2 plus, this value is Vx. I am writing here plus minus, so this is minus VR. And let me call it VR1. Again plus minus, minus VR2. And you are going minus to plus, so this is plus 12 Vx. Correct? And sum of this voltages 1, 2, 3 and 4, sum of this 4 voltage is equivalent to 0. Now we know the value of VR1 and VR2 also. What is VR1? VR1 is 100 I1 minus 2 Vx. So you can say Vx plus 12 Vx is 13 Vx. 13 Vx plus 13 Vx is equivalent to VR1 plus R2. So what is VR1? VR1 is, we are interested in VR1 plus VR2. So 100 plus 60 is 160 I1 and this value is minus 2, 3.2 Vx. So you can say this value will be 160 I1 minus 3.2 Vx. Minus 3.2 Vx2 and 1.2 is 3.2. So you can say this value will be 16.2 Vx equal to 160 I1, or you can say the value of Vx equal to what? 160 divided by 16.2 I1. When I calculate this value come out to be, when I calculate this value come out to be 160 divided by 16.2. This value is 9.87. This value is 9.87 I. If we know the Vx, now we can calculate the everything. Let's go to the first loop. What is the value of V1? So can I say the value of KVL at input? So V1 can be written as what? V1 can be written as 20 times of I1 20 times of I1 minus Vx plus Vx. Why? Because this is plus to minus. What is potential drop here? Potential drop here is 20 times of I1. So this value plus to minus. So this value is equal. But now you know the value of I1. So you can say V1 is equivalent to 20 times of I1 plus 9.87 of I1. When I calculate this, so V1 value is equivalent to what? V1 divided by I1 is 29.87, approximately 30. This is the value of Z1. Once you know the relationship between dependent source and one of the known variable, you can calculate the value of Z11. If you know the value of Z11, we can calculate the value of Z21 also. Because by making I2 equal to 0, we have to calculate V1 and V2 in terms of I1. So what is V2? So you can say from our question, V2 is given by what? V2 is VR2 minus of 12Ix. VR2 minus 12Vx. Or you can say the V2 is what? VR2. What is VR2? VR2 is given 60 V1 minus 1.2 Vx. 60 I1 minus 60 I1 minus 1.2 Vx minus of 12 Vx. Now you know that V2 is equivalent to 60 of I1 minus minus 12 minus 1 minus 13. So this is minus 13.2 Vx. What is the value of Vx? The value of Vx is 9.87 of I. And from here you can calculate the ratio of V2 divided by I1, and that ratio is 13.2 into 9.87 plus 60. When I calculate this 13.2 into 9.87 minus 60, this value is minus 70.284. That ratio is what? That is Z21 parameter. We can calculate the remaining parameter also, and by how we will calculate the remaining parameter? Remaining parameter can be calculated by making I1 equal to 0. So what if I make I1 equal to 0? Let me redraw the network again. I am making 20, 50 and 100. So we are taking 20, 50 and 100. 20, 50 and 100. 20, 50. They are calling this potential as Vx. This potential is 100. And what else is given? 60 and minus plus 12 Vx. So we are having one more branch. This current is not 0 this time. I am taking this current as I2 and I am taking this potential as V2. This potential is V2. What else we want to say? I am making input current equal to 0 and I am telling this current is equivalent to what? V1. This potential is V1. As soon as we make input current I1 equal to 0, I1 equal to 0 means the potential drop across this is 0. If potential drop across 20 is 0, can I say V1 voltage will appear here? And from this analysis we can say that V1 and Vx are same. Because what Vx is showing the potential across potential drop across 50, and what V1 is saying, V1 is also saying the same thing. Correct? So if this current is 0 and this current is V1 divided by 50, who is giving you this current? The current coming to the node is 0. The current coming to the node is 0 and this current is V1 divided by 50. Can I say this current is coming from here? This is also V1 divided by 50 to calculate the KCL. Suppose you are interested in KCL. So KCL is saying what? No amount of current is coming from input, but one current is going away. So second branch should apply the same current, V1 by 50. So what is potential drop here? The potential drop here is V1 by 50 into 100 is 2V1. Now this potential is V1 and this is 2V1. V1 plus 2V1, this potential is what? 3V1. Correct? If this potential is 3V1, what is current in this branch? So you can say I can write 12Vx or I can write 12V1. So what is current in this branch? So current in this branch is given by 3V1 plus 12V1 3V1 plus 12V1 divided by 60 is current in this branch. And current in this branch is given by what? Let me call this current as Ix. Ix current is 15V1 divided by 60 equal to Ix. So V1 divided by 4 is Ix current. If Ix current is known, we can calculate. Now we can calculate everything for this. Can I say what is the value of current I2? The value of current I2, we can apply the KVL. What is KVL? This current is V1 divided by 50 and what is current going in this branch? 3V1 plus this current is V1 divided by 4. So you can say what is value of I2? The I2 is given by sum of this current and this current. So V1 divided by 50 plus we can find the value of I2 from here. We can find the value of I2. I2 is incoming current to the node, KCL at output. I2 is incoming current and what are two outgoing currents? The two outgoing currents are V1 by 50 plus how much we are having? V1 divided by 4. So I can make this equivalent to LCM equal to 100. So this is 2V1 plus this value is what? 25V1. So V1 divided by I2 ratio is what? 100 by 27. and this parameter is known as Z12 parameter. Now we calculate the Z22 parameter also. What is Z22 parameter? Z22 parameter is V2 equal to Z22 parameter. We can say what is V1 equal to? You can say the V1 is equivalent to 100 by 27 I2. And what is the relationship between V1 and V2? Can I say V2 also represents the potential of this point and 3V1 is potential of the same point. So you can say 3V1 is equivalent to V2. If I use this, instead of 3V1, I can write 100 by 27 I2 equal to what? V2. So you can say the V2 divided by I2 ratio is given by 100 divided by 9. Now we know all the parameters. So first two parameters you have to work little bit. The remaining two parameters are very simple. Very simple. So this is the type 2 in the Z parameter, when they will give you some dependent sources, and what is applied to this parameter? Only basic analysis, basic KVL is needed. And this KVL is way more easier because you are making one parameter equal to 0. You are making I2 equal to 0 in the question. So this is second category of question. The first category of the question is what? First category of the question, they will give you resistive network. The second category of question, they will give you the network, linear network with the dependent source. Here we are having the third category of question. In this type of questions of Z parameters, they will ask you to calculate the V1, V2 and I1, I2. Let's calculate for this. This is third very important category, in which some additional network is also connected to the two port, and they are asking that what is value of V1, V2, I1 and I2. So let's calculate this. What Z parameter is given? So you can say one relationship is given here, and that relationship is what? That Z parameter is given. So you can say what is Z parameter? The Z parameter is V1, V2. We want to write V1, V2 as a function of what? Here it is 10 minus 6 minus 4. This is 12. And here we know the value. This value is I1. So Z parameter is given for this internal block, and for this block we can solve these two equations. You can say that V1 is written as 10 I1 minus 6 I2. So V1 is written as 10 I1 minus 6 I2. How you can define the V1? 10 I1 minus 6 I2. And how V2 is written? V2 is written as minus 4 I1 plus 12 I2. So you can say V2 is, what is V2? Minus 4 I1 plus 12 I2. These two values are, wait for a minute. Okay, these two equations are given, and these two equations are given directly. We haven't any circuit analysis. We don't have to do anything about the circuit analysis. Now what else? The else is this. Do we know any relationship? Because we are interested in the 4 variables. If you are having 4 variables, we need 4 equations to solve the 4 variable. So can I say if this current is 3 ampere, if this current is 3 ampere, if this current is 3 ampere and current going away from this node is I1, so can I say the current going in this 4 ohm is 3 minus I1. Now we can apply one simple KVL to get V1. So what I can say, here we are having potential drop of what? Potential drop, let's say this potential I am calling V4. So what is value of V4? V4 is nothing but current multiplied by resistance. And what is current multiplied by resistance? So we are having the value of resistance equal to 4 ohm and current is 3 minus I1. So what this value is? This value is 12 minus 4I1. 12 minus 4I1 is the value of the voltage drop across this 4 ohm resistance. Now, what is the potential drop across this? The potential drop across 2 ohm resistance is given by 2 times of I1. A very simple analysis, a very simple KVL can give you answer for this V1 voltage. So can I say, I am calling this as a loop number 1. So what is the KVL of loop number 1? The KVL of loop number 1, if I am interested in KVL, these 2 equations are given by what? These 2 equations are given by, these 2 equations are given by 2 port directly. Now what we are saying, we are saying that we are applying KVL to loop number 1 because we are interested in the 4 variables. For calculating the 4 variables, 4 equations are required. So 2 equations are already available to us. We are interested in 2 more equations. So can I say, this is V4. I am applying KVL. KVL in loop number 1. If I am applying KVL in loop number 1, what this KVL says? This KVL says that this potential is V4. So V4 is 12 minus I1. 12 minus 4I1 is V4 minus 2I1, and you are going plus to minus, so this is minus V1 equal to 0. This value is what? V4 minus 2I1 minus V1. Fine. So you can say, here we are having the relationship 12 is equivalent to what? 6I1 plus V1. 6I1 plus 1. This is equation number 3 we are having from the network. What is next equation? Next equation is what? The current going inside the network is I2. So can I say current coming out from the network is also I2? If this current is I2, can I say current I2 is entering from here? If current is I2 entering from here, what is the potential drop? The potential drop you are having is plus minus 10 I2. But potential at V2 is mentioned with the opposite polarity. Plus is connected to minus, minus is represented at plus. So you can say the V2 equal to what? We are having one more relationship. V2 equal to minus 10 times of I2. We are having this 4 equations. 4 equations, 4 variable. We can calculate the solution of these equations. Correct? So how we can calculate it? Let's write the value. As we know, if I substitute this value of V2 here, I can find the relationship between I1 and I2. So can I say from equation number 4 to 2. We are replacing the value of V2. So if I write V2 here, minus of 10I2 minus of 10I2 equal to what? Minus of 4I1 minus of 4I1 plus 12I2. Or you can say minus 10 minus 12 is minus 22. I2 equal to what? Minus 4I1. So you can say I1 is equivalent to what? 11 by 2 times of I2. The first relationship we are having from here, I1 is equivalent to 11 by 2. 11 by 2 correct. Now what else? We can say if we know the relationship between I1 I2, we can put this relationship here, I1 I2. So we can calculate the V1 in terms of I1 and V1 in terms of I2 also. So here I am writing from equation number 5 to equation number 1. We are solving these two equations, 5 and 1. So can I say V1 is equivalent to 10 times of I1, 10 times of I1, and this is 11 by 2 times of 10 times of I1 minus 6 times of I2. And one more equation is we are saying I1 equal to 11 by 2 times of I2. So you can say V1 is equivalent to 10 times of I1 minus 11 by 2 times of, because what is value of I2? What is value of I1? What is value of I2? Value of I2 is 2 by 11. 2 by 11 times of I1 into how much? Into you are having 6. Into how much? You are having 6. So this is 6 times of I2. And what is I2? 2 by 11 times of I1. So you can say V1 is equivalent to 10 I1 minus 12 I1 divided by 11. So when you solve this, V1 is equivalent to 110 minus 12 divided by 11 I1. So V1 value is 198 divided by 11 into I1. This value we are having here. Now we are having two value of I1. So two value of I1. This is one of the value of V1 and another value of V1 is available here. So this two value is we are calculating for the same circuit, means these two values must be same. So 12 minus 6 I1 should be equivalent to 98 divided by 11 I1. So you can say 12 divided by 98 divided by 11 plus 6, and this is the value of I1. So you can say the value of I1 for the circuit is 12 divided by 98 by 11 plus 6, and this value comes out to be 98 divided by 11 plus 6 into 12. This value is I1 and I1 value is 0.759 ampere. If value of I1 is known, we can find the value of V1. And what is value of V1? The value of V1 is 98 divided by 11 into I1. And what is I1? 0.759. So 98 by 11 into 0.759, this value is 7.43. 7.43 volt. Now we know the two value. The value of I1 is known. The value of V1 is known. If value of I1 and V1 is known, if value of I1 is known, the value of V1 is known, we can calculate the value of V2. So what is V1? In this question, the V1 is given by 7.43. So let's use this equation. V1 equal to 10 times of I1 minus 6 times of I2. What is value of V1? The value of V1 is given as 7.43 volt. Equal to 10 times of I1, 0.759 minus of 6 I2. So when I calculate this value will be what? This value will be what? This value will be 10 into 0.759 minus 7.43 divided by 6, and this value is I2. The value of I2 will be and if value of I2 is known, we can calculate the value of V2. So all value can be calculated. So this is another variety of problem. This is another variety of problem. In this variety of problem, we are interested in what? They give one external network, and across the external network, you have to calculate the current or voltage or anything. So this is the standard question. So we are calculating everything across V1, V2, I1, I2. Otherwise, they will ask one or two variable for this network. So this is type 3 of Z parameter they can ask. What is next type? The next type we are having is this. The next type is this. What they can ask? They can ask the Thevenin's equivalent of a two-port network. So they will give you two-port network like this, and they will ask what is the Thevenin's equivalent of this two-port network. And why we are interested in Thevenin's or Norton's equivalent? Because with the help of Thevenin's and Norton's equivalent, we can calculate the maximum power transfer also. So this two-port network is given, and they are saying that what is the Thevenin's equivalent across this two-port network. So always remember, this two-port network, the Z parameter is given, and what is Z parameter of this? The Z parameter of this two-port network is given by Z11. This is given Z12, Z21 and Z2. The Z parameter is given, and take them these values at Z11, Z12, Z21 and Z22. So Thevenin's equivalent we are calculating. So if we are calculating the Thevenin's equivalent, as we know that how to calculate the Thevenin's equivalent, just remove this load from the circuit. If you remove this load from the circuit, across this load we are interested in calculating the Thevenin's equivalent. Across this load ZL we are interested in the Thevenin's equivalent. So let's calculate it. Can I say this is V1, this is V2, this is I1 and I2. So one equation is given, and what that one equation? The equation for the two-port network is given, and what they are saying? They are saying that given equation given, what is given? That V1 is equivalent to Z11 I1 plus Z12 I2, and V2 is given as Z21I1 plus Z22I2. These two equations are very much available to us. These two equations are available to us. What else are available? First, just write what is available to us. Okay. What else is available to us? The current coming from this node is what? I1. So you can say this potential drop is I1 into Z of S. If this potential drop is I1 into Z of S, can I say the value of V1 is Vs minus this potential drop is V1. So Vs minus what else is given? The next relationship which is given from the network, external network, Vs minus I1 into Z of S equal to V1. This relationship is also given. And if we remove this from the circuit, we don't know what is V2 and I2. So let's calculate this. Suppose you are interested in the Thevenin's equivalent, how Thevenin's equivalent works. So can I say the Thevenin's equivalent is nothing but a voltage source that represents the open circuit voltage with series resistance ZTH, and we are calling this voltage as your load voltage. We are calling this voltage as ZL. So we are interested, this is known as Thevenin's equivalent. So ZL is load, so we are interested only two values. What is first value? The first value is VTH, and VTH is also known as open circuited potential across load. Open circuited potential across load means just remove the load and calculate the open circuit voltage across it. And ZTH is known as what? ZTH is known as Thevenin's equivalent resistance. Equivalent resistance. So we are interested in this two parameter. Can I say if I remove load from the circuit, what is the task? Task is to calculate the open circuit voltage. So can I say the open circuit voltage or this V2 voltage is representation of same variable when I remove ZL from the circuit. Open circuited voltage or Thevenin's voltage or V2 is the same thing when I remove this ZL from the circuit. So if ZL is removed from the circuit, let's take the case number 1. When you are removing, let's say we have removed ZL from the circuit. Let's say ZL is removed from the circuit. If ZL is removed from the circuit, if it is removed from the circuit, what is its effect? Its effect is the value of I2 will be what? The value of I2 will be 0. Why value of I2 will be 0? The value of I2 will be 0 because no current can flow in open loop. And value of I2 will be 0 and V2 will represent the open circuit voltage or this will represent VTH. This is the whole picture. Now what I can say, we are having some equations, so put the value in that equations. So V2 will be VTH and I2 will be 0. If I2 will be 0, this value is what? Z21 into I1. This is equation number 2 dash. New modified equation by making I2 equal to 0. And what is the value of this? The first equation will become V1 times of, it is equivalent to V1 times of what? Z11 into I1. If this is Z11 into I1, but what is 0? I2 is 0, so this is Z11 into I1. But if we are calculating the Thevenin's equivalent is always defined for what? Thevenin's equivalent is defined with respect to the supply you are connecting. So can I say this value will be V1 can be written as Vs minus I1 into Z of S equal to Z11 I1. If I bring this variable here, the value of Vs is equivalent to I1. I can take common from the circuit, and this value is what? Summation of Z11 and Zs. So I can write the value of V1. The value of V1, value of I1 is what? The value of I1 is given by, the value of I1 is given by Vs divided by Z11 plus Zs. But we are not interested in this value. We are interested in what? We are interested in the value of V2. And how you define the V2? V2 is VTH, and VTH is Z21 into I1. So let me write this value. VTH is Z21. What this value is? Z21 into I1. And I1 we know. Vs divided by Z11 plus Z of S. Z11 plus Zs. And this voltage is known as Thevenin's voltage. So what we can, how we define the Thevenin's voltage? The Thevenin's voltage VTH, Thevenin's voltage VTH equal to VOC, and this value is given by what? Z21 divided by Z11 plus Zs multiplied by S. This is the idea for Thevenin's equivalent voltage. So this represents what? This represents Thevenin's equivalent voltage. If you want to convert this two-port network into a two-port network with additional supply into a Thevenin's equivalent. Correct? Now we are interested in calculation of ZTH. So how to calculate the ZTH? This is very interesting thing. The idea of calculating the equivalent resistance is very simple. How we do this? If this is our network, how to calculate the ZTH? So calculation of ZTH is very simple. Make independent source equal to 0. Make independent calculation of ZTH. Remember, this is ZTH. And we are recalling the concept of calculating the ZTH. What ZTH says? ZTH says that if this is your network, make all independent sources equal to 0. So if you are having voltage source, represent it by short circuit. If you are having current source, represent it by open circuit. So all independent means calculation of ZTH. How you calculate the Thevenin's resistance? We are making all independent sources equal to 0, and we will connect one test source here. This test source is having value Vt, and this test source is drawing current It. Then what you say? This Vt divided by It ratio is, you can call it ZTH or you can call it RTH. Okay, let's apply this in our network. So if I applying the test source here, can I say the V2 will be replaced by Vt? Because if I say I am interested in applying, if I am interested in applying a test source here, you are applying test source like this. So now this is no more a reading of a voltmeter. This is what? This is test source you are applying, and this will draw current I2. So I2 will be It. Correct? So can I say for calculation of ZTH, what will be the V2? V2 will be the Vt. What will be the I2? I2 will be the IT. This is available to us. What else we want to study? What else we want to know? We are making all independent sources equal to 0. So only one independent source is available here, voltage source. So if I make this source equal to 0, the new relationship I am having from the circuit is what? The new relationship from the circuit, we are making Vs equal to 0. We are replacing this current source by 0. So what is value of V1? The value of V1 is minus I1 into Zs. The value of V1 is minus I1 into S. Correct? Now we can use these relationships now. So V1 is minus I1 into Zs. I am putting this value from equation number 3 to equation number 1. From equation number 3 to 1. If I am going from equation number 3 to equation number 1, can I say equation number 3 to equation number 1, can I say minus of I1 into Z of S is equivalent to, because this is V1, and what is V1 equal to? Z11 I1. So I am calling this Z11 I1 plus Z12 into I2. So I2 is now IT. So what is the value of this? You can say this value is minus of I1 if I take common from here. This is Z of S plus Z11, and this value is Z12 into IT. Or you can say, what is the value of I1? The value of I1 for the circuit is given by minus Z12 divided by Z11 plus Zs into IT. Fine. This is one of the value we are having. Now we are interested in what? V2. So what is V2? As we know that V2 is Z21 I1 plus Z22 I2. So if I write the value of V2, now I will not write V2 because V2 is replaced by VT test source. So can I say the value of V2 will be VT? V2 is Z21 into I1. But I am not interested in I1 because I am interested in the ratio of VT by IT. So I1 is given in terms of IT minus Z12 divided by Z11 plus Z of S into IT. And what else? This is V2 equal to Z21 I1 plus Z22 I2. So second part is Z22 I2. And what is I2? I2 is IT. So we are interested in the ratio of VT by IT, and VT by IT ratio represents what? The VT divided by IT represents what? ZTH. So what is value of ZTH? The value of ZTH is Z22 minus Z12 into Z21 divided by Z11 plus Z of S. This is the value of ZTH. So can I say the value of ZTH for here? This is the value of VTH, and if you are interested in RTH or we can call this as ZTH. The value of RTH or ZTH is given by, this value is given by what? This value is given by this. Z22 minus Z12 into Z21 divided by Zs plus Z11. This is the value of RTH. This is how you can calculate the Thevenin's equivalent of the given circuit. This is one more variety of the question you can expect in your exam. Next, let's go for this. What is next variety? The next variety here is next variety of these questions. In this type of questions, they will ask you the value of ZL for maximum power transfer to the load. So one load is given, and across the load we want to transfer the maximum power. So this question is based on which combination? Two-port network and maximum power transfer calculation. What is and they are asking for the maximum power delivered to the load. So always remember, whenever you are interested in the maximum power transfer, always remember the idea of maximum power transfer is very simple. Maximum power transfer can be obtained. Maximum power transfer can be obtained if we are here. If we are having this. If I am calling this potential as VTH and equivalent resistance is represented by RTH. When you are having, always remember the maximum power transfer is all about the choice of load, not choice of this. This is given. So you can say this value, what should be the value of this network so that maximum power can be transferred? This value should be RTH. So once you know the value of Thevenin's equivalent, you can find the value of ZL. Value of ZL which is responsible for maximum power transfer. So can I say the value of ZL is given by ZTH or RTH. Correct? How to calculate the RTH for this network? So let's calculate the RTH by the same method. What is given? The two-port parameter of this Z parameter of this network is given. So can I say what is Z parameter? The given equations are what? Equation is V1 equal to, the first row is 40I1 plus 60I2. 40I1 plus 60I2. This is equation number 1. What is equation number 2? Equation number 2 is V2 equal to 80I1 plus 120I2. These two values are given. These two values are given. What else is given? What else is given? It is given that, because how we represent it, we call it V1. This value is I1. We call it V2. And this value is I2. So if they are saying that they are interested in RTH, RTH means what? We will remove this load from here and we will connect one VT here, and this VT will supply current IT by making independent source equal to 0. So if I make independent source equal to 0, what is the value of V1? So you can say this potential drop is 10 times of I1. So you can say V1 equal to minus of 10 times of I1. So this is 0 and this is minus 10 times of I1 equal to V1. So can I say when we are calculating RTH, we can say I2 should be replaced by IT and V2 is replaced by VT. So we are interested in the VT divided by IT ratio. This is the overall agenda. Can I say we are having one relationship V1, and what is value of V1? The value of V1 is minus 10 times of I1 from which relationship? Because whenever you are calculating the equivalent resistance, all independent sources must be 0 inside the network. So this is one independent source, this must be 0. So what is value of V1? V1 is equivalent to minus 10 I1. So let's put this value here. If you put this value here, what is V1? V1 is minus 10 times of I1. Minus of 10 times of I1 equal to 40 I1 plus how much? 60 I2. But 60 is now 60 I2 is what? 60 IT. So you can say minus of 50 I1 equal to 60 IT, or you can say the value of I1 equal to what? The value of I1 is equivalent to minus of 6 divided by 5 I1. This we know. But we are not interested in this. We are interested in V2 by IT ratio, VT by IT ratio. So if I put the value in second equation, this VT is equivalent to 80 times of I1. But we are not interested in I1. So I1 can be replaced by minus 6 divided by 5 IT, minus 6 divided by 5 times of IT, and this is 122 or 120 of IT, because what is I2? I2 is IT, and this VT by IT ratio, if I take IT common from here, it is 16. 16 6 is minus 84, minus 96, minus 96 plus 120. So 24 is correct answer. What is RTH? So RTH is 24. If RTH is 24, can I say, if RTH is 24 means if suppose this maximum power is transferred from source to load, if this voltage is 24, what is this voltage? This voltage must be 24 also. Now we are interested in VTH, and how to calculate the VTH? To calculate the VTH, make current I2 equal to 0, because if you make current I2 equal to 0, in this network, if I make current I2 equal to 0, this node is open circuited, and VTH is what? VTH is open circuited potential. So I am making I2 equal to 0. So the VTH calculation, Thevenin's equivalent calculation, is given by what? VTH. So you can say the node value V2 will be VTH, or the same value is called as V open circuit voltage, only if you are making, only if you are doing what? Only if you are making I2 equal to, only if you are making I2 equal to 0. So if I make I2 equal to 0, this value is 0, this value is 0. So you can say relationship we are having is V1 equal to 40 I1 equation number 1. What is next equation? V2 equal to 80. V2 is what? V open circuit, VTH, equal to 80 times of I1. Correct? But V1 is not source voltage. So source voltage is what? We are having equation for the source voltage. Source voltage V1, and you can say, what is V1? So you can say this potential is V1, and this is I1. So what is potential drop here? The potential drop here is 10 times of I1. So you can say the value of V1 is what? The value of V1 for the circuit is 120 minus of 10 I1. RMS value is given, that's why we will get the RMS value of the Thevenin's voltage also. If source is RMS, whatever your voltage you will get across the circuit is RMS, and whatever current you will get is RMS. So this is 120 minus 10 I1. So can I write V1 equal to what? 120 minus 10 I1 equal to 40 I1. Or you can say 50 I1 equal to 120. This is 0, this is 0. What is I1 equal to? I1 equal to 12 divided by 5. If I1 equal to 12 divided by 5, you can say the VTH equal to what? 80 into 12 divided by 5. This is 16. So 12, this is 8. No. 160 plus 24. 160 plus 24. You can say what is 16 into 12. This value is 192. So what is VTH? VTH is 190. If VTH is 192 volt, we know everything about this circuit. This is 192 volt. If this is 192 volt, we are interested in the maximum power, but this circuit diagram is also true for the maximum power, and we are interested in the power across this component. So what is power across this? Power across this is given by current across this and voltage across this. So what is current across this? Current across this 24 is given by what? 192 divided by 48. This is the value of current. And what is the voltage across 24? 192 divided by 48 is current, multiplied by 24 is the voltage across it. So you can say 192 divided by 48 multiplied by 192 divided by 48 into 24. This product will gives you the value of maximum power transfer. So whenever we are interested in the calculating maximum power transfer, that value is 192 whole square divided by 48 whole square multiplied by 384 watt. So this is another category of question. They will ask question related to the power transfer across any load or anything. So just try to, whenever they ask question across the power transfer or power across any load, try to convert your figure into the Thevenin's equivalent. This is the method. So this is our discussion on the basic 3 to 4 types of problem which is generally asked in the exam, and these are 3-4 categories of problem. Now let's take one more problem is remaining in this. One more problem is here. We are not yet we have not discussed the y parameter, so only calculate which parameter here? Only calculate z parameter for this network. And we know how to calculate the z parameters for this network. To calculate the z parameters for network, we have to redraw the circuit. Or if you are able to identify that which two components are in parallel series and which two remaining two components are in series, you can calculate that also. If I am saying this value is V1, correct, and this value is V2. If I am making this current as what? I1. If I am saying this current is I2. Let's make I2 equal to 0. If I make I2 equal to 0, can I say if I make I2 equal to 0, can I say the current here will be what? If this current is Ix, this current will be I1 minus Ix. Correct? This Ix current will come here. This Ix current will come here. And what current you are adding into the network? You are adding zero current. If you are adding zero current, the same current will flow in this circuit. If current is same, can you say these two resistances are in series combination? I am saying this value is Ix. I1 current is coming from the source. So can I say Ix current is going inside this? RA Ix current is also coming to you don't have to redraw the network again and again. This is Ix, and here we can say this current is also Ix. Now, what is this current? This current is I1 minus Ix. If this current is I1 minus Ix, can I say no current is coming? If current entering into the node is 0, so current will exit is also equivalent to 0. So can I say same current will flow in this? I1 minus Ix. Correct? And this current is what? I1 minus Ix. I1 minus Ix plus Ix is equivalent to what? I1. So this current is I1. Very simple. Entering current is I1 and current exit from that node is also I1. So can I say this two components are in series and these two components are in series. So we can calculate this. We can draw this. How much we can draw here? Let's say this is your point 1. So one branch is having this. One branch is having this. One branch is having 8 ohm and 16 ohm. Same current means these are in series. Another branch is having 4 and 12. 4 and then we are having 12. This value is V1, this value is I1, and they are calling this current is 0, this is plus minus of V. Now we can calculate 8 plus 16 is 24 and this is what this value is 4 and 12. So what is current in this branch? The current in this branch is given by because I2 current is 0, so you can say 12 plus 4 is 16. 16 divided by sum of all this resistance. 24 plus 16. 24 plus 16 is 30, 40. This much of I1 equal to V1. So we can calculate the value of Z11 and Z11 is 8 2s are 8 5. This value is 0.4. So we have solved this type of question in our fundamental analysis. In our introduction, we have talked about this type of ladder network. So I hope this discussion is clear. We have discussed the varieties of question. Now in the next section, what we will do? We will try to learn when this Z parameter will be symmetrical, when this Z parameter network can be reciprocal, and how to connect the Z parameter in series or in cascade, how we can connect it. Then we will solve some previous year problem, then we will go to the Y parameters. So I hope this is clear. Thank you very much.